So you guys have this already, right? So we've done simplifying. You guys remember? Roderick, you ready? So we've done I will see if I can zoom in. So I can't zoom in anymore. I will zoom in a little bit as I do it, but I don't have another seat for you to sit. Oh, okay. So you should have simplifying. You should have excluded values. You should have how we multiply and divide. And then anytime you guys are struggling this unit, I should see you getting your cheat sheet out to look at that before you ask me for help. Because at this point, everything that's on your cheat sheet, you should be good at. We should be able to do it. Even if it takes us some time, we should be good at it. All right? You guys added a little bit on your own about you added a little bit about finding common denominators. And now as a class, we're going to do adding and subtracting. Yeah. I would just maybe fill in if you see that we write something and you're like, that'd be helpful. But if your notes are already good enough, then I wouldn't worry about it. All right, so if we were doing adding and subtracting fractions, what is the very first step we always did?
Common denominator.
Yeah, so factor the denominators to find the common denominator. So we factor the denominators to find the common denominator. Once we knew what the common denominator was, what did we do after that?
Then you took what the other fraction didn't have.
Yeah, so we're going to say we want to make sure that each fraction has the common denominator. So make sure each fraction has the common denominator. Now I'm going to write a note to myself. When we do this, we're going to multiply out the tops. So if you need to distribute, then you should distribute. If you need to FOIL, you should FOIL. Okay, so the tops always get multiplied out completely. I'm going to say leave the bottoms in factored form. Does anyone remember why we leave the bottom in factored form?
Cancel?
Yeah, it might cancel at the end. Okay, once you have two different fractions that have that common denominator, what's your next step? Yeah, combine them so that they look like one fraction. So write the two fractions as one fraction. And combine like terms. after you've combined like terms, you have all your like terms together on the top, what is our last little bit that we have to do? Simplify. And in these problems, what does it mean to simplify? Factor and cancel. So to make sure that our cheat sheet is effective for us, we're going to go ahead and do an example problem. That's a good way to make our cheat sheets. So we're going to do 2x plus 3 over x squared minus 1. And we're going to subtract x over x plus 1. Okay, step 1. What was step 1? Factor. How do we factor x squared minus 1?
X plus x. Oh wait, no.
X plus 1, x minus 1. How do we factor x plus 1?
X. Oh wait, no, this stays.
It stays the same. It's in parentheses. Good. All right, so what is our common denominator? What's our common denominator? X plus 1, x minus 1. Okay. So we finished step 1. Step 2 is what?
Now you gotta plug it in. So
Make sure that both of them have the common denominator. So if I look over here, I'm going to go ahead and rewrite this so that my notes make sense. So this is step 2 we're doing. Oh, sorry.
So would that be x squared plus 1 or no?
So the first fraction stays the same. What do I need to do on the second fraction?
X minus 1.
Yeah, x minus 1 on the top.
Sorry, x minus x squared with x.
No, you were right. It was just x minus 1. Yeah. And then we always make sure to multiply out the tops. So the first fraction, again, is going to stay the same. And I am leaving the bottom in factored form. And what do I get for the second fraction on the top?
X squared minus 1x minus x.
Yeah, minus x or minus 1x, that's the same thing, right? So whichever way you write it is fine. So third step is to write it like one fraction, right? So x plus 1, x minus 1.
Then you do 2x minus 3 or plus 3?
Plus 3.
Plus 3 minus x squared minus x.
Wait, be careful. Plus x, yeah. So what do we get when we combine like terms?
You got x cubed, negative x cubed, right?
X squared.
Yeah, we still have a negative x squared.
What is it?
3.
That's, you can't combine x squareds and x's. You can multiply them, but you can't combine them to make an x to the third.
So I thought when the x, never mind.
So if you multiplied x squared times x, that's how you get x to the third, but not by adding.
But why doesn't it why doesn't one x?
It is, you just don't have to write it.
That's why I was like x cubed.
Yeah. But you don't add your exponents together. So 2x and 1x makes 3x. And then what else do we have? Plus 3. And then step 4 is to factor and cancel tops and bottoms if you can. What do you guys notice about the top?
You gotta do a diamond.
Yeah, it looks like a diamond problem. Are we allowed to leave the negative in the front? No. So we take the negative out, and that would give us x squared minus 3x, right? Because we divided out a negative. And then minus 3. So if we tried to factor this, we say we're looking for something that multiplies to negative 3 and then adds to negative 3. Doesn't work. So this is not factorable. What does that mean for our final answer? We can leave it where it was. So not factorable. So that means that the original with the negative in the front is fine. Or we could leave the version where we took out the negative. Both of them are equally correct. Those are both good answers.